Hello ladies and gentlemen, this is section 3.3, Proving Lines Parallel. As a reminder, any of the theorems or postulates we go over you can find located between pages 926 and 931. So today is all about the converse theorems and postulates to what we talked about in section 3.2. Our first being postulate 16, the corresponding angles converse, which says if two lines are cut by transversal, so the corresponding angles are congruent, then the lines are parallel. So instead of the original, which was if the lines are parallel, then the corresponding angles were congruent. This is saying if the corresponding angles are congruent, then the lines are parallel. So if we can somehow show that corresponding angles are congruent, we can know the lines are parallel, even if it's not given to us in the problem with these parallel markings. We can deduce that using deductive reasoning and using our postulates and theorems. So again, if we can show the corresponding angles are congruent, we can logically conclude that the lines are parallel. Starting with an example, and this will look very similar to examples we've gone through before, find the value of x that makes line M parallel to line N. Well, if they're parallel, then these corresponding angles must be congruent. So we need to find x so that those are congruent. So 3x plus 5 equals 65. Subtract 5 from both sides, so 3x equals 60. Divide both sides by 3, so x is 20. So again, this is x is 20 because that makes these corresponding angles congruent, which we need in order to show that these two lines are going to be parallel. For another example, we're going to see, is there enough information to conclude that those two lines are parallel? Well, we don't see any corresponding angles congruent yet, but let's see if we can use vertical angles and linear pairs to make that happen. I know that 105 is a linear pair with this missing angle here. So if I take 180 minus 105, since linear pairs are supplementary, I get 75. So this missing angle here is 75 degrees. And now that these corresponding angles are both 75, we can conclude that they are congruent. So the answer is yes. Using linear pairs, or a linear pair, we know that corresponding angles are congruent. So our lines are parallel by postulate 16. Corresponding angles converse postulate, which I prefer the name, but for the sake of the notes, I'm just writing the number so we can make this video a bit shorter. So this is an example of explaining how you know the two lines are parallel. Now, we have three theorems regarding this as well, our alternate interiors, alternate exteriors, and consecutive interiors. These are kind of wordy though. These are the descriptions in your book. So to make it a bit shorter, if alternate interior angles are congruent, then the lines are parallel, just like with the corresponding. Likewise, if alternate exterior angles are congruent, then the lines are parallel. And if consecutive interior angles are supplementary, then the lines are parallel. So we can use any of these angle pairs. If we can show that any of these are occurring, we can logically conclude that our lines are parallel. If we cannot show one of these four relationships, then we cannot show that they are parallel. That's our little inverse. So let's do some examples with these theorems. Again, you can pause if you need to copy these down. They're also in your textbook in the section 3.3 or in the range 926 to 931 pages. So can we prove that these lines are parallel? For number 3. We see here that both of these angles have one curve in them. That means they're congruent to each other. And these happen to be alternate exteriors. So yes, because of our alternate exterior converse theorem, which says that if alternate exterior angles are congruent, then we can conclude these lines are parallel. For number 4, again, yes we can. We see one curve mark on both of these angles and they're corresponding. They're both in the bottom right corner. So since corresponding angles are congruent, we can conclude that the lines are parallel. So that's going to be our corresponding angles converse postulate. We can conclude that those lines are indeed parallel. You're probably thinking we haven't had a no yet, so 5 will probably be no. Yes, 5 is no. We're told that these two are supplementary. They add to give us 180. Well, those are alternate interiors. Alternate interiors are not supposed to be supplementary. They are supposed to be congruent. So this is no. One of two reasons you can say. One, there's no theorem or postulate that we can use to back ourselves up here. Nothing about alternate exterior angles being congruent or supplementary. So no, because we don't know any of those, and because alternate interior angles should be congruent, not supplementary. That was the issue. So we have a yes, and no. But let's move on to something involving proof. In the figure, we're given some information we're going to use at some point. We know that R is parallel to S, and 1 is congruent to 2. We want to prove that these other two lines are going to be parallel. So of course we start with our given information. And we want to somehow show that one of those 4 angle pair relationships are happening between these two lines. Notice that 2 and 3 are formed by those two lines and this transversal for R. Those two angles are alternate interiors. If we can show that they're congruent, we can know that those two lines are parallel because we're making one of those 4 relationships happen. So in this case, I want to show that 2 is congruent to 3. Well, so far, I know that 1 is congruent to 3, so I need some sort of statement with 2 in it before I can move to 2 being congruent to 3. Well, since these two lines are parallel, I know that corresponding angles, 1 and 2, should be congruent. And that's our corresponding angles postulate, not the converse, just the postulate from section 2. Now, because 1's congruent to 3 and 1's congruent to 2, we can cut out the 1's and leave 2 and 3 congruent to each other. That's an old favorite. That's our transitive property, which is like our best friend when we're proving these things. And finally, since we know that these alternate interiors are congruent, we know that our lines are parallel. One of our 4 relationships are happening. And that's our alternate interior angles converse theorem. Since alternate interior angles are congruent, then we can conclude our lines are parallel. Now that's a 2-column proof. I mentioned in class that you can do this in a paragraph form if you'd like to as well. So as a result, I'll show you a quick example of that. I'm just going to leave it up here for you all to examine. Just for a moment, so you're going to want to pause it. This is a paragraph example. You can probably write this a little bit shorter if you'd like to, as long as you have all the needed information, all of your given information, all of your reasons, and all of your statements from the 2-column. Just write in a few sentences. So again, I'll pause this and leave it up here. Otherwise, I'm going to move on to the next example / the last theorem we're going to talk about. The last thing is the transitive property of parallel lines. If 2 lines are parallel to the same line, they're parallel to each other. So if I were to say these 2 lines are parallel, P and Q, and Q is parallel to R, then P is also parallel to R. We can cut out the middleman. Transitive property. Cut out the Q's and just leave P is parallel to R. That's our transitive property of parallel lines in a quick nutshell. So a quick example. The flag of the United States is 13 alternating red and white stripes. Each stripe is parallel to the stripe immediately below it. Explain why the top stripe is parallel to the bottom stripe. Well, if these two are parallel, and 2 and 3 is parallel, and 3 and 4 is parallel, and all the way down the line, all of them are parallel to each other, it's using our transitive property of parallel lines. It's also kind of like the law of syllogism with that DirecTV commercial. If you keep cable, then you'll be on hold. If you're on hold, you get angry. If you're angry, You blow off steam. If you blow off steam, accidents happen. If accidents happen, etc., all the way down the line. And you cut out the middle stuff and just leave the beginning in the end. That's the law of syllogism, or in this case, we use it as the transitive property. That concludes lesson 3.3. I hope this video is helpful. Remember to ask any needed questions you have in class, before class, or after school.